Hi there, and welcome to part 2 of episode 4. In this video, we'll dive deeper into the visual assets of the player scene. We'll explore various elements including image editing software, basic and animated sprites, as well as collision shapes, all of which play a crucial role in creating an engaging 2D gameplay experience. Let's get started. First, before we create our sprites, we need to have our assets ready. You can use image editing software such as GIMP, Photoshop, Blender, or any other suitable program to design and edit your image textures. You can also purchase or find tile sets and sprite sets on the internet. I personally use GIMP because it's completely free, and while it has a high learning curve, it has some very powerful features that rival the big names. Image editing software allows you to create and modify visual assets for your game. You can design characters, objects, backgrounds, animations, fonts, and more. Make sure to choose the software that best fits your needs and your skill level. The results of this process are your raw image files that will be used as textures for our game sprites. Now let's explore sprites and textures in more detail. The texture is the underlying image used by the sprite. We use PNG files for our images, but these can be other formats as well. In many cases, these files can contain a single image. However, they can also contain an entire atlas of images contained in a grid. Using multiple images in a single texture file helps manage resources efficiently, reducing draw calls and improving performance. We also use textures that contain multiple images to help run animations, which we'll see here in a few minutes. Those are sometimes referred to as sprite sheets or animation sheets. Sprites are the visual representation of objects in our game. The player, the enemies, the world tiles, the item pickups, and the projectiles are all sprites or combinations of sprites. They're composed of an underlying image texture, which we previously described, as well as various settings to control how to shape and scale the image. Think of a sprite as a picture frame that displays part or all of a texture. In Godot, we'll use the Sprite 2D class to put it together. We'll load the texture into the sprite using the inspector. And even though we don't use it here, we can also adjust the region of the texture that will shine through on the sprite. Next, let's delve into the animated sprites and their various components. In Godot, we'll use the animated Sprite 2D class to assist with animating our character. We have our move animation ready to go in a texture image named pcanim.png. The main components of an animated Sprite 2D are the Sprite Frames, the animation name to be played, the current frame being displayed, and the speed to play the animation. We'll come back to the Sprite Frames in a second. We give meaningful names to each animation, making it easier to identify and manage them. For example, in our game we have two animations, Default and Move, which makes using them in code very easy. The current frame on the animated Sprite 2D can be changed if we wanted to start on a specific frame. We won't be using it here. And the speed scale controls the animation's playback speed. So what about the Sprite Frames? Sprite Frames represent the collection of named animations that will be used. In our game, we have two animations in our Sprite Frames. The first animation is named Default and represents the player standing still with no real animation. We can add a single frame to the default animation using this icon and choosing the pc.png file. Now, if we play the animation, we'll see that it's not exactly exciting, being only one frame repeating over and over. So we can add another named animation to the Sprite Frames and call it Move. And here, we'll use this icon to add frames from a sprite sheet texture file. Using this interface, we can use the different settings at the top to chop up the combined image into rows and columns, or just columns in our case. Once we select our frames, those images will be added to our Sprite Frames for further inspection. We can add more frames as needed. Now, if we play the Move animation, we'll see our wonderful AAA walking animation. Here's where we could modify the speed scale to adjust the animation to our liking. A value greater than 1 makes the animation faster, while a value less than 1 will slow it down. When the game starts, the player will be in the default animation. In our game, the player's actions trigger different animations. For example, when the player moves, we switch to the Move animation. By updating the current animation name and code, we can transition between different animations. This can be accomplished using the play and stop methods like this. That covers the basics of a simple animated sprite 2D. Let's talk about these child sprites. We enable and disable these sprites in code, when the player performs certain actions like picking up a shield or a weapon, or when taking damage. In our game, we have several child sprites. These are drawn on top of the animation. The shield and the pistol, these have image textures attached to them. The boots and the key do not have images, at least in this version. And here is a special child sprite with a timer, Sprite Damage. This sprite serves a specific purpose and appears briefly when the player takes damage. It uses a Godot timer node to control its visibility duration. We'll see more details on how the state machine works in the next part of episode 4. Now let's move on to the collision shapes and their role in the game. Collisions are essential for handling interactions between objects in the game world. We could probably write an entire video on handling collisions and the collision signals, but for now we'll keep it basic and rely on the built-in 2D physics engine in Godot. Because our player scene is based on the character body 2D class, we need to add a collision object in order for the physics engine to work. In Godot, we'll use the collision shape 2D class to give the player's character that hard surface that it needs. The most important property of this class is the shape field, but there are a few other callouts that we'll see in a second. The shape of the collision body defines the player's hitbox. We're using a capsule shape for the player, as it closely matches the character's image, but we could use another shape if we needed to, like a circle or a rectangle. We won't do it here, but you can even add multiple collision shapes to make a more complex hitbox. We'll see that in episode 5 when we talk about the game's boss that has multiple hitboxes. During development, it's helpful to visualize collision shapes. We set a debug color to display the collision's collision shape in the game world, allowing us to fine-tune and verify collision interactions. These can be turned on and off in both the editor and in the game depending on your needs. Now that the player scene has a collision object in place, we can go back to the player scene itself and adjust things further. Collisions between physics objects are determined by their collision layers and masks. In our game, the player's collision layer is set to collide with the tiles of the level. We can and will customize these settings further to achieve many different gameplay effects, but for now, this will allow the player to walk in the game world without falling through the floor. With everything in place, the player's movement interacts realistically with the physics objects. The move and slide function, used in our state machine, will handle the player's movement while considering collisions with the environment like the level's tile map. And that concludes part 2 of episode 4. Stay tuned for part 3 where we'll explore camera setup, the player input controls, and the state machine that manages the various states like walking and jumping. If you're enjoying this series and finding it helpful, please consider liking and subscribing to our channel. Your support motivates us to continue creating valuable content. And if you stuck around this long and happen to be developing a Godot game that you want us to showcase on the channel, send us a comment. We'd love to share some of your games and experiences with our audience. Thank you for watching and see you in the next video.